So good afternoon, class.
Good afternoon.
Yeah, are you ready for the practical?
Yes.
Yeah, so we're going to verify the Archimede'S principle, which states that when a body is fully or partially immersed in a fluid, it does what? It experiences an upthrust equal to weight of the fluid displaced. So we're going to do an experiment to verify that statement. So we are first of all going to take an object and we read its real weight in air. So we have a mass already with us. Can we get the real weight of that mass? Can we get the real weight of that mass? The real weight of the mass from a spring balance. So can you read carefully and accurately? 0.3 newtons. Can you record it? 0.3 newtons. 0.3 newtons. So now we are going to submerge this mass in water. The liquid we have here is water. Therefore, we are going to submerge this mass in water. Then, by the time we are submerging it in water, which will be contained in a Eureka can, there must be another beaker which will be empty to collect the water which gets displaced, right? Yes. So the first thing we do is to determine the mass of this empty beaker. So the empty beaker, can you determine its mass using the weighing balance? Using the weighing balance. Place it there and read for me the value. 11.0
grams.
Good. Record 11.0 grams. 11.0 grams. Okay, now that we have a mass of the empty beaker, we can now assemble the apparatus such that the Eureka can is just below the mass, and under the spout of the Eureka can, we have the empty beaker. We have the empty beaker. Carefully. Don't immerse the solid unless the empty beaker is ready. Unless the empty beaker is ready. Good. Now we can gently submerge. Gently. As some water gets collected in the empty beaker. Yeah. So can you record for me? While the solid is submerged in water, what is the new weight, the apparent weight? The apparent weight?
0.16 newtons.
Yes, you're seeing it?
0.16.
0 point? Are you in agreement?
Yes.
0.16. Good. Record? 0.16. Now, the time we were submerging that solid in water, it has displaced some water. Through the spout of the Eureka can, some water has been collected in the beaker which was empty. Remember, we had determined the mass of the empty beaker, but now it is containing some water. So can we get mass of the beaker together with the water which is displaced? Yes?
27 grams.
27.
Yes.
Okay, record. Now that we have mass of empty beaker and mass of beaker containing water, then we can get mass of water displaced. Mass of water displaced. Mass of water displaced. That must be subtraction. Mass of water displaced. Mass of water displaced. 16 grams.
Yes.
16 grams. 16 grams. That is good. 16 grams. So can you convert now? Can you convert the mass of water which has been displaced into weight? Which means you first of all make the weight SI unit by dividing it by 1,000. Then you multiply by G. 0.16. 0.16, huh?
Yes.
Good. 0.16 newtons. 0.16 newtons. 0.16 newtons. So I want us now to compare two values. The upthrust, which we had determined by subtracting real weight and apparent weight, and the weight of the water that has been displaced. So what values are you realizing it is? What is the value of the upthrust?
0.16 newtons.
0.16
newtons.
What about the water displaced?
0.16.
Are you really getting my question? I want people to determine first. Tell me the value we had gotten when we subtracted real weight and apparent weight. The values must be very close to one another, or the same, or even the same. Very close to one another, or even the same. 0.14, eh? 0.14 was the upthrust, but now we are finding the weight of water displaced is 0.16. Good. So actually, if you convert to mass, you realize the weight of water displaced converted to mass will be 16 grams. Are we together?
Yes.
And again, you realize the upthrust experienced, when we convert that weight into mass, it is 14 grams. So 14 grams and 16 grams. The difference is only 2 grams, right?
Yes.
Only 2 grams. Therefore, it is very true that when an object is submerged in a liquid, the upthrust it will experience will be the same as the weight of the liquid it will displace. And that is the conclusion by Archimedes' principle. So that is the lesson. Thank you for watching us. Subscribe and share.
Thank you.